Here's an example working through an IB high-level style problem dealing with trigonometric identities. The given problem was that the sine of x plus pi over 3 is equal to 2 times the sine of x times the sine of pi over 3. That's given information, so in other words, that equation happens to be true, and that information is enough to show that the 11 times the tangent of x is equal to some number times some other number times the square root of some number, whatever. So what I thought I would do is try to approach this problem from the perspective of, at the very least, taking the given information and pushing it as close to finding a tangent as I possibly can. So the very first step of the process is to convert into the sum form using compound angle identity as shown here. So in other words, the two underlying pieces were given information, and what I did is I filled in the middle with the identity on the left. So anyway, here's the identity, here's the given, and my job then is to rearrange the equation until I get something I can work with. So the first thing I do is I evaluate the cosine of pi over 3. I also evaluate, let's see, there's the cosine of pi over 3 is 1/2, and over here is the sine of pi over 3, which is square root of 3 over 2. Over on the right-hand side, the sine of pi over 3 was equal to square root of 3 over 2. I multiply that by this 2, and that's why I just have square root of 3 sine of x. Alright, moving forward, I divide everything by the cosine of x so that my equation just has tangents in it. Now that I have everything in terms of tangents, I'm going to solve for the tangent of x just to see what happens. So, first I double both sides of the equation to get rid of the fractions. I get all the tangenty stuff over on one side. I collect like terms, aka factor out a tangent of x. Thanks, you're welcome. And divide both sides by 2 square root of 3 minus 1. So this doesn't look exactly the way the format is on the item question, but at least I have the tangent of x equals something. So the next issue is to look at the form, and what I see here is if I multiply top and bottom by the conjugate, then that will rationalize the denominator, and working ahead, I think that the denominator is going to be 11. And indeed it is, so we multiply 11 times the tangent of x, we multiply both sides by 11, we get 11 tangent of x equals 6 plus the square root of 3. So the format that the authors intended here was that the 11 tangent of x would be equal to a plus b root 3. So what I can do is verify that this is the correct form, because the a is a 6 and the b is a 1. And therefore I have the correct form and everything's great.